Hello, today I'm going to explain the project of question answering using Squad 2. So first of all, I have done all the import statement in one place. And while talking about the import statement, I have used UV for the package manager. And you can see we can use a CPU for the TensorFlow, which is not Linux. And for Linux environment, I have used TensorFlow with CUDA, which have GPU support. So I have run all the project on the Linux. So you can see I have a GPU bootstrap here. I just print the TensorFlow version, and just to check the physical device that I have listed in GPU. That I have one GPU, and then I have done the have saved everything in the config so that it increase the reproducibility, and it can be reused in any sort of things. It's we can change epoch number, dropout, everything from the config file above the code. So we don't need to manually go to the code and update everything. Yep. So from here we start our actual project. So we have a token pattern that is just a regex to compile the pattern, and we have a QA example class with the required variables, and I have token with spans that will just take the text and then it will just give the output in the tokens and the span form. It will just find use the regex and find iter on the text, and then it will just append on the tokens and span and just response those token and spans. If you just want tokens, I have another function for tokenize text. It will just tokenize all the text and send it. It will not handle about the spans. Yep, and this function is actually for start and end token session. So char underscore span to token span. What it basically does is it handles the potential overlappings and the full commitment token entirely inside the answer span. And we have a value squad split. So it basically splitting, we are just loading the JSON file and then split it. We have JSON file on the dataset folder, and it's just a function. We are going to call the functions like 2 times for train sample and for the dev sample. So these are to train sample and dev sample. So training sample is gonna use for training the model, and dev sample is gonna use for testing that model. And then I have just used load is squad split. That's gonna split our sample, train sample and dev sample, and it will be train examples and dev examples. I have just printed the length of the train and dev examples. Those are 130,000 of training examples, and 11,000 are dev examples. And then we have build dataset frame. So it's gonna build basically it's gonna build a table that is a frame, a dataset frame df. So here we're gonna use a split name, ID, title, questions, and all these from the dataset train and the dev both. So we just quickly check the profile df data frame head. So it basically gives you the 4 topmost data. We basically split these are the titles and these are the top 5 data. So we can see those data and visualize what type of data frame do we have. So this is the actual data frame. So in summary, I have done profiling of group by. which is split and average of all these data. So you can see the average of all these data in the dev dataset and the trained dataset as well. Now here comes the data visualization. It's none other than exactly same thing that we have done above. So it's, for example, like the token context of the training context is like is mostly like 400 to 600 tokens. So there is few of the context which goes beyond like 600 or 800 characters, sorry, 800 tokens, but most of them below is like on 0 to 200, that is like almost approximately 100 tokens. And here also like the question tokens are mostly like maximum it's like 37, and mostly it's around 10. So 10 tokens of the questions, amount of questions are like more than 30,000, and these are like how many of them are answerable and how many of them are not answerable. So more than 80,000 is like answerable questions we have, and we have like more than 40,000 of unanswerable questions. So now let's talk about vocabulary. So first of all, we have built the vocabulary, and then we just insert the globe and load the globe embeddings. So globe is like global vectors. So we have the embedding strategies, encoding tokens, vectorized examples, and yes, of course, for both vectorized examples for the training and the dev features. After that, we have like data frame ready for the like context and the questions. So these are the feature sets. Like now the actual model architecture starts, which will have like input layer, embedding layer, encoding layer, and the attention layer. Finally, after completing, we'll have the output layer that will have the result. So we have bidirectional attention. We have bidirectional attention and softmax class. And we have the main function build model. So on the build model, we have an embedding layer. First of all, input layer that we talk about context and the questions. Those were the like feature set, and they are in the input layer. And then we have the embedding layer for both like context and the question. And then we have an encoding layer. After that, we have attention layer. Finally, after that, we have the output layer. So we can see the model summary. So this is our entire model summary. And now let's go to the training section. Here we have built our model using like model.fit. The epoch number is like 10. You can see here. So it is already pre-configured in the like top of our code, as I showed earlier. So we have saved our trained model in the history variable, and this training goes on. So you can see like up to 4 epochs it trains regularly, but after that it stops training because like if you see the loss variable, we can see like it's 3.0. Sorry, 3.80, and in the second iteration, second epoch, it's like 3.61, which is like reduced. So the loss is reduced, means the model is getting better. But after that, in the third iteration, third epoch, it's like 3.64. It's worse than second one, and finally, like it's 3.82. It's nearly like 4, or it's nearly like the first epoch. So concurrently, two of the epochs are worse than like second epochs. So we just stop the training here just to prevent like overtraining or like overfitting issues, and we just save the data of second epoch in our model. So it's just the data frame. We just get the history data that we get trained model and just try to find out the tail. It means like last four data samples that will just give the high level overview about how a table look like. Now we can also plot that in the figures. So you can see like the variable loss is like 3.8 on the first epoch, and it's below like it goes almost like 3.6 in the second epoch, and more than 3.6 in the third epoch, and more than 3.8 like in the fourth epoch. So that one is the best for us. The evaluation matrix. So I have just normalized the answer to evaluate and compute exact, and then compute F1, and then decode span, predict the data set. Finally, I have working it on the dev data set. So previously we were working on the training frames. Now after the model training is completed, we have used a dev frame to like predict the data set. And then these are the output, like the F1, you can see the F1 here, and the exact match is all 1 and F1 is all 1. It means like it is working fine for these entries. Yep. So you can see like a gold answer is the answer that is actual in the data set, and a predicted answer is the answer that we predicted from our model. All of them are almost like identical. So this seems very good. But we also have, this is just a sample of the dataset, but we also have like a whole bunch of dataset, and I just created the summary of that. So it says like the answer accuracy, answer accuracy is like 58% of the time it is correct, 42 of the percent of F1, and 37% of exact match. So we have the confusion matrix here. So it basically says like the predictable answer is S and the gold answer is S, which means our model is correct in like 4,619 and also correct in like 2,847, because predicted answer is no. Predicted no answer. The model says it's there is no answer, and the gold no answer. Like actually in the dataset there is no answer. So these two are the right thing. But also you can see like predictable answer is 3098 times, like it predict the answer. Like it can predict the answer, but in actual there is no answer. So there is a huge data here, and which is wrongly evaluated by our model, and this one is also wrongly evaluated by our model. Like it says predicted no answer, our model predicted no answer, but there was answer in the data set. So you can see like it's a 58%, and if we like just calculate these to sum and calculate is, it's gonna be like 58% of accuracy in no answerable prediction, which is not so good. But we can add, we can like improve its accuracy using like maybe 300B data. I'm just using 100B. It's just a short comparison table for like exact match and F1 with like sorting them. So it's all the data that have no F1 and that have no exact match, which means like goal answer and predicted answer are contradict. So you can see like these are the questions where our model get failed. For example, when did this integrative emerge? So goal answer, there is no goal answer, but our model predicted in the 10th century. So there is one mismatch. our model predicted wrong thing, and here as well there is answer, but our model cannot predict it. So these are the sample data. And finally, I have some QA demo. So it is just getting the data from the data frame, like which we are using for testing purposes, and we just use random location, and get them ask them to predict the answer. So here is the question, context, question, and predict answer is France. It is confidence, like its confidence is like 91.9%. It's confident like 50%, and there is no answer. So these are the things like first row, fifth row, and the 100th row. But we can do it like a lot of times and check it and change the hyperparameters and tune it more. So at last, I have saved them in the path like artifacts, dev prediction.csv and evaluation metrics.csv.